Hi grade 8. In this video, we're going to look at solving equations with a variable on both sides. This will correspond to section 1.3 of the textbook. So let's just jump right into our first example. Our first example is 15 take away 2x is equal to negative 7x. And then at the end, when we get our solution, we're going to double check our work to make sure that we're correct. So the strategy when we are solving for the equation when the variable is on both sides is that we're trying to have it so the variable is only shown on either one side of the equation, so either on the left-hand side or on the right-hand side. So if I look at this first example, I can see that I've got negative 7x by itself on the right-hand side of my equation, and I have negative 2x on the left-hand side of the equation. So ideally, I want to have those variables be on the same side. So what I'm going to do here is I'm going to add 2x to both sides of my equation, because whatever I do to one side, I have to do to the other. And when I do that, it's going to eliminate this variable of x on my left-hand side, and I'm going to be left with 15 is equal to negative 7 plus 2x is going to be negative 5x. And you see how we've just created that the variable is only on one side of the equation. So now this looks like any other problem that we solved from before. So now we're going to divide both sides by negative 5. This is going to cancel, and we're left with 15 divided by negative 5 is negative 3 is equal to x, and that is our solution. And then, of course, we're going to double check our work to make sure it makes sense. So we haven't got any errors in this. So if we do that one, we've got 15 take away 2 times negative 3 is equal to negative 7 times negative 3. And we're going to check if both sides of our equation are equal. So 15 take away 2 times negative 3 is negative 6, equal to negative 7 times negative 3, which is going to give us 21. And now I've got 15 subtract negative 6, which is positive 21, equal to 21. Both sides of the equation are equal, so that lets us know that we did this first example correct. So taking a look at this second example, I've got negative 3 plus 5a is equal to 4a take away 10. Now what we're going to do here is a little bit different because this equation has two terms on each side. So a term is just anything that's separated by an addition or subtraction sign. So this is one term here, negative 3, and positive 5a is another term. And then on this side I've got 4a, that's a term. And I've got negative 10, which is another term. So do you see, on both sides of this equation, we have two terms. When we have more than one term on one side of the equation, this is when we can think of a different strategy. So now I'm going to look at the coefficients of my variable. The coefficient is the number in front of my variable. So if I look here, my 5a has got a coefficient of 5, and this has got a coefficient of 4. So when I'm doing this now, I'm going to look at those two coefficients and I'm going to figure out which one is bigger. Which one is bigger in this case is the 5. 5 is bigger than 4. So I'm going to leave the 5 alone, and what I'm going to do is I'm going to subtract 4a from both sides. And the reason why I'm subtracting 4a is because in front of this 4a is a plus sign that we're not showing, so it's positive. So I'm going to subtract 4a from both sides. That's going to cancel here. And then I'm going to be left with negative 3 because I haven't done anything with that yet. And I've got 5 take away 4a, which is going to be positive a, is equal to negative 10. And now this looks like any other equation you've solved before. I'm going to add 3 to both sides. This is going to cancel. I'm going to be left with a is equal to negative 10 plus 3, which is going to give us negative 7. So that's my solution for that one. Now I'm going to check it to make sure that it's correct. So I'm going to do negative 3 plus 5 times negative 7 is equal to 4 times negative 7, take away 10. So negative 3 take away 35 is equal to negative 28, take away 10. And that's going to leave me with negative 38 is equal to negative 38. Both sides of the equation are equal, which tells me that we did this one correct. Now taking a look at example 3, we've got negative 5, and then we've got in parentheses negative 4x take away 6 is equal to 5, and then in parentheses 6 take away x. Hopefully now you're seeing that we have to expand our brackets before we can start solving this one. So we have to multiply negative 5 times negative 4x, and we've got to multiply negative 5 times negative 6. We've got to multiply 5 times 6 and 5 times negative x. So negative 5 times negative 4x is going to be positive 20x. Negative 5 times negative 6 is going to be positive 30, is equal to 5 times 6 is 30. And then 5 times negative x is going to be negative 5x. All right. Now we're going to decide which is going to be like our first move. So we look at the coefficients of our variable. We've got 20x here, and I've got negative 5x here. Now I'm going to look for the one that is bigger. So 20 is bigger than negative 5. So I'm going to do the opposite of negative 5, which is going to be adding 5x here. So plus 5x and plus 5x. Now the reason why I'm doing this is because I could do it the other way. I could have done, let's say I rewrote this again, I've got 20x plus 30 is equal to 30, take away 5x. I could have done take away 20x from both sides, and then I would have been left with 30 is equal to 30, negative 5, take away 20x is going to be negative 25x. And I could do it that way, which is perfectly fine. However, in the way that we've done it, we're going to have now 25x plus 30 is equal to 30. Now, personally, I just find that when the coefficient or the number in front of the variable is a positive number, it just saves us from making some mistakes, which is why I chose to look at which number has the bigger coefficient. So doing it in this method is perfectly okay. It just leaves us now with this negative coefficient in front of our x. So if we continue with this, now we've got 25x plus 30 is equal to 30. I'm going to subtract 30 from both sides. This is going to cancel. I'm going to be left with 25x is equal to 30 take away 30 is 0. I'm going to divide both sides by 25. And I'm going to be left with x is equal to 0. And of course, again, we could double check our work by substituting that back into our equation and finding out if both sides of the equation are equal. So moving on to our last example, we have negative 2 times, in parentheses, x take away 5 is equal to 6, and then in parentheses 2 take away 0.5x. So in this example here, we're going to want to do distributive property. So negative 2 times x gives us negative 2x. Negative 2 times negative 5, positive 10, is equal to 6 times 2 makes 12, and 6 times negative 0.5 gives us negative 3x. And now I'm going to look at this, and I'm going to look at the coefficients of my variable. I've got negative 2x, and I've got negative 3x. I'm going to leave the larger of the two, so the one with a larger coefficient, alone, and then I'm going to work with the negative 3x, because negative 2 is bigger. And what I'm going to do is I'm going to do the opposite of subtracting 3x, which is adding 3x to both sides. So I'm going to have plus 3x here and plus 3x here. Now, I don't have to do it like this, so let's just copy this and put this down here to look for later. So let's just continue with our example. So if I continued here, I would have this cancel, and I'm left with negative 2x plus 3 gives me x plus 10 is equal to 12, and then I'm going to subtract 10 from both sides. That's going to cancel, and then x is going to be 12 minus 10 is 2. So x is going to be 2. And I'm going to leave it like that. Now, let's take a look at the part that I just copied down again. So I did tell you that we want to look for the one that has the larger coefficient. So the negative 2 is the larger coefficient. So that's why I added 3 to both sides. Now, if you were to do it the other way, so instead, let's say you looked at it and you said, okay, I'm going to add 2x to both sides. That's perfectly okay, and you'll get the same answer. So let's just continue with that. We get this is going to cancel, and then I'm going to get 10 is equal to 12, and then negative 3x plus 2x makes negative 1x, so negative x. So now I've got that negative coefficient in front. And then I want to subtract 12 from both sides because there's a positive sign in here that we don't see, so take away 12 from both sides. And then I have 10 take away 12, which is negative 2, is equal to negative x. So now I've got negative 2 is equal to negative x. I could divide both sides by negative 1. So I could divide this by -1, divide this by -1, because there's that invisible 1 here that we don't write. So -1 divided by -1, that's going to cancel here, so we're left with x. And then -2 divided by -1 gives us +2, so 2 is equal to x. So if you notice that we arrived to the exact same answer, so both ways will give you the same answer. I just like it sometimes when we have a positive coefficient in front of the x. However, this may not always happen. Sometimes you get stuck with a negative coefficient, and that's okay. You just have to remember that you do have a negative coefficient in front of that x. Here are 4 questions for you to try out on your own. Remember, if you get stuck, rewind the video and look at the different examples again. So try out the 4 questions, and I'll see you guys tomorrow in class. Bye!